Today we're on page 10 of our Chapter 14 notes packet, section 14.7, forces. In the first two pages on page 10 and 11, we're going to walk through two worked out problems, and on the last page we'll do 4 problems together. If two forces act to push or pull an object in different directions, the effect is that of a single force acting in a direction between the two forces. Okay, so here we have a larger force and a smaller force. Forces are represented by a line segment or vector, where the length is the magnitude and the arrow is the direction. When two forces act on an object, the single force that has the effect as the combination of the two forces is called the resultant. So this is a vocabulary word you need to know. The resultant is the result of two forces acting on a single object. Now, what we have here, whenever you see the words forces, what you're going to do is you're going to draw a representation of it. And the representation originally starts like this. You have your larger force, which would be a longer segment, and the smaller force, which would be a shorter segment. And then you're going to create a parallelogram out of this. And the resultant would always be the diagonal of the parallelogram. All right. The resultant is always going to end up being the diagonal of the parallelogram. So let's look at these two, or the first example. You have two forces of 25 and 15 pounds act on an object so that the angle between them is an angle of 75 degrees. All right, so here we have our larger force of 25 and our smaller force of 15. And the angle between them is 75. Next, create a parallelogram, which is drawn here. Now, draw the resultant. We want to find the magnitude of the resultant. So now draw the resultant. That's the diagonal of the parallelogram. That's between the two forces. Okay? And we know that the angle between the two forces is 75. Well, now with the parallelogram, all right, what's this consecutive angle measure? It's 105 because it's a supplement of 75. Consecutive angles in the parallelogram are supplementary. So now if we work with this triangle, okay, and it's a parallelogram, so we can move this 15 over to here, and also if we wanted we can move 25 up to here because opposite sides of a parallelogram are congruent. So now looking at this triangle, we need to find the resultant. And it's labeled lowercase b because it's opposite angle b. And in order to find that, all right, so all three sides are represented, so we use law of cosines. And law of cosines would say that that side of b, that b squared, is equal to the sum of the squares of the other two sides. So we would have b squared is equal to the sum of the squares of the other two sides. So it's equal to 15 squared plus 25 squared minus twice the product times the cosine of 105. Right? So then we would go to the calculator and key in the square root of 15 squared plus 25 squared minus 2 times 15 times 25 times the cosine of 105. Rounding to the nearest integer, that would be 32. So b is going to equal the square root of that whole thing, and b is 32. So the resultant force is 32 pounds. Next example, we have a resultant force of 143 pounds, is needed to move a heavy box. Two forces act at angles of 35 degrees 40 minutes and 47 degrees 30 minutes with resultant. Find to the nearest pound the magnitude of the larger force. All right, so we draw our parallelogram. The resultant, the diagonal between the two forces, is 143. Now, the placement of the angles, the 35 degree 40 minute and 47 degree 30 minute, is dependent upon the sides of our parallelogram. All right, or if I take half the parallelogram and look at this triangle, this is the shorter side, so the shorter side opposite that would have to be the smaller force. I'm sorry, the smaller angle. So the smaller angle has to be opposite the shorter side. So the 35 degrees 40 minutes would be placed here. And then this is the longer side. And looking at this triangle, the longer side, the angle opposite that would have to be the larger angle. All right, so the larger angle needs to be placed here and the smaller angle here. Okay, now we're still working with the parallelogram. So these are parallel. So if this is 35 degrees 40 minutes, then treating this as a transversal, these two angles are the same. So we can put 35 degrees 40 minutes up here, or these two angles are alternate interior. So over on this side, this is 47 degrees 30 minutes. And now we can work with either one of our two triangles. I'm going to keep it with this triangle. Okay, so we know two angles of the triangle. We can easily find the third by adding these two and subtracting the result from 180. And I'll tell you that ends up being 96 degrees 50 minutes. Now we want to find the nearest pound, the magnitude of the larger force. Here's the larger force, right? It's the longer side. That's our larger force. It's represented by C, so we use law of sines here because we have two sides represented. So C over sine 47 degrees 30 minutes is equal to 143 over sine 96 degrees 50 minutes. That's what we have down here. C over sine 4730 is equal to 143 over sine 96 50 minutes. Cross multiplying, solving for C, plugging into the calculator, and we get 106. Okay, now working these out together. If two forces of 30 pounds and 40 pounds act on a body with an angle of 120 degrees between them, all right, right away we have forces of 30 and 40. The angle between them is 120 degrees, so I'm actually going to try and draw a parallelogram that's representative of that, in that I'm going to slant it this way, right? So at least this will give me the appearance of a obtuse angle. So this is my shorter side, so that's our smaller force, and this is a larger force. And this is a 120 degree angle between them. I finish out my parallelograms. All right. Now the resultant, again, is always the diagonal between our two forces. We want to find the magnitude of that resultant. Okay, well we've now split the parallelogram into two triangles, so let's work with one of those two triangles. I'm going to move the 30 over to here, to the opposite side, and if this was 120 degrees, then this consecutive angle of the parallelogram would be the supplement 60 degrees. We want to find the resultant. I'm going to label that x. What do we have here in our diagram? With our triangle, we have all three sides represented, so we're going to use law of cosines. So we start with the side opposite the angle, so x squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides and the cosine of the included angle. So x is going to equal the square root of this whole thing. Again, always please get your variable by itself before you go to the calculator. Make sure you're in degree mode. So square root of 30 squared plus 40 squared minus 2 times 30 times 40 times the cosine of 60. To the nearest pound, nearest whole number, 36. Number 2, two forces act on a body. Right there, you're thinking a parallelogram. The measure of the angle between the 34-pound force and the 40-pound resultant is 60. Find the magnitude of the other force to the nearest pound. Okay, so we have a 34-pound force and a 40-pound force. It says the measure of the angle between the 34-pound force and the 40-pound resultant is 60. Okay, sorry, the 40-pound is a resultant. Cross that off. Find the magnitude of the other force to the nearest pound. Okay, so we're finding the other force here. The measure of the angle between the 34-pound force and the 40-pound resultant, so between the 34 and the 40, is 60 degrees. Not quite sure if 34 is our smaller force or our larger. Okay. Let's place the x. I'll just move it up to here. And now looking at our top triangle, we have all three sides represented. So this is law of sines again. I'm sorry, law of cosines. This is law of cosines again. All three sides of our triangle are represented. So our side of x squared is equal to the sum of the squares of the other two sides minus twice the product times the cosine of our angle. So x equals the square root of this whole thing. Go to the calculator, square root of 34 squared plus 40 squared minus 2 times 34 times 40 times the cosine of 60. To the nearest pound, 37 pounds. Number 3, when forces of 12 pounds and 8 pounds act on a body, the magnitude of the resultant is 15 pounds. Find to the nearest degree the measure of the angle between the resultant between the resultant and the larger force. Okay, so we have our two forces, our larger one, 12, and our smaller force of 8. And the magnitude of the resultant is 15. Find to the nearest degree the measure of the angle between the resultant and the larger force. Remember, this is our resultant, and this is our larger force. So we want to find the measure of this angle right here. Call that x. For our parallelogram, I'm going to work with this triangle, so I'll transfer the 8 over to the opposite side. And once again, we have all three sides represented, so law of cosines. So that side of 8 squared is equal to the sum of the squares of the other two sides, minus twice the product of those two sides, and the cosine of our angle. Okay, so here we're trying to find, first isolate cosine x, so let's get rid of the addition here, so subtract. So we have 8 squared minus 12 squared minus 15 squared equals negative 2 times 12 times 15 times cosine x. And now undo the multiplication, divide by negative 2, 12, and 15. So we have cosine x is equal to this fraction, so x is going to equal the cosine inverse of that fraction. So we have our variable x by itself, so now let's go to the calculator. Second cos alpha y equals 8 squared minus 12 squared minus 15 squared divided by negative 2 times 12 times 15. To the nearest degree, 32 degrees. Okay, in our last one, we have two forces act on a body so that the resultant force is 50 pounds. The angles between the resultant and the forces are 25 degrees and 38 degrees. Find the smaller force's magnitude. Two forces act on a body so that the resultant is 50 pounds. So here's our resultant, the diagonal, that's 50 pounds. The angles between the resultant and the forces are 25 degrees and 38 degrees. So 25 has to be opposite the shorter side, and the 38 needs to be opposite the longer side. So 25 degrees has to be opposite the shorter side, this side, and 38 has to be opposite the longer side. We want to find the smaller force's magnitude. Okay, so smaller force is our shorter side. We want to find this. So I can bring this 25 up to here, because these are alternate interior angles. Or if you prefer working with this triangle, I guess this is really my preference. I would bring the x over to here. Working with this triangle, this is 38. And I know just the one side of 50. I need to find the other side, the smaller force. And right now I have two angles. I do need to find the third angle. I need to find the angle measure of the angle that's opposite our 50-pound resultant. Okay, so 25 and 38 subtracted from 180 gives us 117. This is law of sines, right? Because we only have two sides represented. So this is law of sines. X over sine 25 equals 50 over sine 117. Cross multiply x times sine 117 equals 50 times sine 25. Get x by itself, divide by sine of 117, and we have x equals 50 sine 25 divided by sine 117. And go to the calculator. Alpha y equals 50 sine 25 divided by sine 117. Find the smaller force's magnitude to the nearest pound. That'd be 24. And this finishes our chapter 14 notes. Thank you.